Okay, so picture this. Crazy hair, a twinkle in his eye, and that equation, the one EMC ashore, always floating around somewhere close by. I mean, that's basically our shortcut image for genius.
Yeah. Yeah, the visual shorthand, for sure.
And it all points back to one man, Albert Einstein.
Born March 14th, 1879.
Died April 18th, 1955.
And the textbooks usually call him a German-born American theoretical physicist.
Which, okay, it tells you something that it doesn't really capture the impact,
Yeah,
right?
At all.
Like, this guy shifted our entire understanding of how the universe works. So that's what we're doing today, taking a deep dive to get past the surface and really understand Einstein.
Right. We've got a detailed biography here, tons of information, and our goal is to give you the essential Einstein, to cut through all the noise and make it clear why he matters so much.
Exactly. So where does this journey begin? According to the biography, where did Einstein come from?
Well, it all starts in Ulm, a city that was part of the German Empire back then.
Okay.
Born into a Jewish family, and what's interesting is they weren't, super academics themselves, but they were really supportive of his intellectual curiosity from a young age.
That's cool. So you've got this encouraging home life, but then he hits the German education system.
Oh, yeah, and that's where things get interesting.
Yeah, because the biography talks about his struggles, how he felt out of place, almost isolated in that kind of rigid school environment. And it's kind of ironic when you think about it, right?
It is, because this is the guy who'd go on to become the ultimate symbol of revolutionary thinking. So was it just the system that was the problem, or did Einstein's own way of thinking play a role too?
It makes you wonder.
Yeah, and from what the source says, it wasn't just a matter of him not liking the classes.
Oh, okay.
He had a seriously independent mind, He wasn't into rote learning. He wanted to visualize things to really understand the concepts, and that probably clashed pretty hard with the whole memorization and discipline style of teaching.
Makes sense. But, I mean, he obviously had a natural gift for math and physics, right? That must have broken through eventually.
Oh, absolutely. The biography makes it clear, there's no denying his talent in those areas. He didn't just scrape by. He excelled, which tells you something, Even with those early obstacles, if you have that much passion and ability, it's going to come out eventually.
I like that.
Yeah, so that passion leads him to the Polytechnic Institute in Zurich, which is ETH Zurich today.
Right, and he graduates in 1900 with a degree in physics and mathematics. But here's the thing that always gets me. This guy, this future Nobel Prize winner, he struggles to find a teaching job right out of school.
Oh, yeah.
It's kind of a humbling reminder that even the most brilliant minds, they don't always have it easy.
Definitely. It shows that the path to making a real impact, it's not always straightforward.
No.
But eventually he lands a position as a technical assistant at the Swiss Patent Office in Bern. Now, that might sound like a total sidetrack from theoretical physics, but the biography really emphasizes how crucial this job was for him.
Really? In what way? It seems, pretty bureaucratic.
Yeah, but that's kind of the point. The patent office gave him a steady paycheck, which is always nice, but more importantly, it wasn't super demanding. He had time, he had mental space to think, to explore his own scientific ideas after hours. So while he's evaluating other people's inventions, his mind is off in the cosmos, building these new frameworks for understanding the universe. It's pretty amazing when you think about it.
So this ordinary job becomes the unexpected springboard for some extraordinary ideas.
Totally.
And then we come to 1905.
1905. The miracle year, the annus mirabilis, as they call it.
In the biography, it really hammers home how incredible this year was. Einstein publishes 4 groundbreaking papers in Annalender Physik. It's almost hard to wrap your head around the sheer volume and impact of his work in that one year.
It is.
And one of those papers, that lays the groundwork for what we now know as the special theory of relativity. So let's break that down. What's at the core of this theory?
Okay, so the special theory of relativity is built on 2 main ideas, 2 postulates, as Einstein called them. The first one is that the laws of physics are the same for everyone, no matter how they're moving, as long as it's at a constant speed. So imagine you're on a train that's moving smoothly, not speeding up or slowing down, and you bounce a ball. The physics of that bouncing ball, it's going to be exactly the same as if you were standing still on the platform.
Right.
The second postulate is the one that really bends your mind a bit. It says that the speed of light in a vacuum is constant for all observers. It doesn't matter how fast you're moving or how fast the light source is moving, the light will always travel at the same speed. So picture this. You're on that same train, but this time you shine a flashlight. Someone standing on the platform watching you zoom by, they're going to measure the light beam traveling at the same speed as you would, even though you're moving really fast.
Yeah, the second one definitely takes a minute to get your head around.
It does.
But these two deceptively simple ideas, they had huge implications for our understanding of the universe, right?
Oh, absolutely. Massive implications. Because what it meant is that our ideas of space and time, they weren't absolute anymore. They were relative. They depended on the observer's motion. And out of this framework comes maybe his most famous equation, EMC.
Great.
And what this equation tells us is that mass and energy, they're essentially interchangeable. You can convert a tiny amount of mass into a tremendous amount of energy, and the other way around. That's the whole idea of mass-energy equivalence.
Okay, so EMC tech, I mean, it's everywhere. T-shirts, movies, you name it. But beyond the pop culture fame, what's its real significance? Why does it matter so much in physics?
Well, think about it like this. It's one of the cornerstones of modern physics. I mean, it explains how stars, like our sun, generate their energy through nuclear fusion. And it explains why nuclear reactions release so much power. EMC basically changed how we understand the energy balance of the entire universe. That's pretty huge.
No, that is huge. So we have special relativity, this groundbreaking theory. Then, 10 years later, Einstein takes it even further. 1915, he unveils the general theory of relativity. And this time, he's tackling gravity. So how was his view different from what Newton had proposed all those years ago?
Okay, so Newton's idea of gravity was all about forces, right? Like objects with mass attract each other.
Right.
But Einstein, he flips the script completely. He says gravity isn't a force at all. It's a curvature of space-time caused by mass and energy.
Space-time. So that's like the fabric of space and time all woven together. And you're saying massive objects actually warp this fabric, and that's what we experience as gravity.
Exactly. Imagine you have a stretched rubber sheet, like a trampoline, and you put a bowling ball in the middle. The bowling ball represents a massive object, like a star or a planet, and it creates a dip in the sheet. Now, if you roll a marble across the sheet, its path is going to curve inward towards the bowling ball because of that dip. That's a simplified way to visualize how massive objects distort space-time and affect the motion of other objects around them.
Okay, yeah, that analogy really helps. And there's this really cool event that happens in 1919, right?
Yes.
The biography talks about this expedition to observe a solar eclipse led by Arthur Eddington.
Yeah, a big moment for Einstein.
Totally. So what did they see during this eclipse?
Well, what they observed was light from distant stars bending as it passed close to the sun. And the amount of bending, it matched perfectly with what Einstein had predicted based on his general theory of relativity. I mean, this was huge. It wasn't just a theory on paper anymore. It was actually observed. It was real.
Wow.
And of course, that observation, it made Einstein a global superstar. It's not every day that you see light, which we think of as always traveling in straight lines, bending around a massive object like the sun. It just captured people's imagination.
Totally.
It was like, okay, this guy is onto something really big.
And this fame thrusts him into a whole new arena beyond just science.
Well,
the biography goes into his later life and how he became more and more involved in political issues. And then in 1933, with the rise of Hitler in Germany, Einstein, being Jewish, makes the difficult decision to immigrate to the United States.
a huge turning point, both for his own safety and for the future of science in America.
Yeah. So he ends up at the Institute for Advanced Study in Princeton, New Jersey. And that becomes his home base for the rest of his career. But he doesn't just stay in his academic bubble.
Oh,
right?
no, not at all.
The biography makes it clear that he uses his newfound platform to speak out about the things he cares about.
Right.
He becomes a vocal advocate for peace, for democracy, for basic human rights, and he's really critical of things like nationalism, unchecked military power, and any kind of totalitarian regime. The book really emphasizes his pacifist beliefs, which is interesting because then World War II happens, and there's a noticeable shift in his thinking, right?
Yeah, it's one of those moments where you see the complexity of his views. He was deeply concerned about the possibility of Nazi Germany developing nuclear weapons. So even though he was a pacifist at heart, he actually ends up signing a letter with other scientists, urging President Roosevelt to start the U.S. atomic program.
Wow.
And it really highlights how sometimes even the most deeply held beliefs can be challenged when you're faced with what feels like an existential threat.
It's that whole idea of like the lesser of two evils almost.
Right, exactly. And his commitment to social justice, it goes beyond just international conflict too. He was very involved in the American Civil Rights Movement.
Oh, right. The biography mentions that.
Yeah, he was a big supporter of equal rights for African Americans, and he worked closely with the NAACP to try to make that happen. He saw a connection between the persecution he had witnessed in Europe and the discrimination that Black people were facing in the U.S., and he felt compelled to speak out.
It's pretty incredible that he was willing to put his reputation on the line for these causes. So let's talk about the official recognition of his scientific achievements. He wins the Nobel Prize in Physics in 1921. But it's fascinating to learn that he didn't actually win it for what most people think.
Yeah, you'd think it was for relativity, right?
Yeah.
But no, it was actually for his discovery of the law of the photoelectric effect.
Right, and remind me what that is again?
It's basically the phenomenon where if you shine light on a metal surface, it can knock electrons loose.
Okay.
And this was a big deal because it provided evidence that light behaves as both a wave and a particle. And that was a key step in the development of quantum mechanics.
It's almost ironic that his less famous work earned him the Nobel Prize.
It is, but it kind of shows how multifaceted his genius was. I think that the photoelectric effect, while it was super important for physics, it's maybe not as conceptually mind-blowing for most people as like the idea of time being relative or gravity warping space-time, but it was absolutely crucial for our understanding of the quantum world.
So it's clear from the biography that Einstein's impact goes way beyond his theories. His legacy is huge.
I mean, he's one of the most influential scientists of the 20th century, hands down. His theories of relativity, they're still the foundation of modern cosmology and astrophysics. And even though he had some reservations about certain aspects of it later on, he played a big role in the development of quantum mechanics. It's like he was constantly pushing the boundaries of what we thought we knew about the universe.
And the biography throws in some really cool tidbits about his life, too. Like, did you know he was offered the presidency of Israel in 1952?
Wow, I didn't know that.
Yeah, it's in there. Of course, he declined, but it just shows how much respect he had on a global scale. And apparently he loved music, too. He played the violin.
Really?
Yeah, it makes you think, maybe there's a connection between scientific creativity and artistic creativity. Like, maybe they tap into the same underlying principles of structure and harmony.
Interesting thought.
And this one always blows my mind. He had trouble with language as a kid. He didn't really speak fluently until he was like 9 years old.
Really? That's
Right.
wild.
It's a good reminder that where you start doesn't always dictate where you end up.
Totally.
And of course, we can't talk about Einstein without mentioning how Amy Seikoff has become this pop culture icon.
Yeah.
It's like a symbol of scientific insight, even for people who don't really get the physics behind it.
It's true.
The biography also touches on his personal life, his marriages to Mileva Maric and Elsa Lowenthal, and his children, including Hans Albert. And there's this, kind of odd detail about his brain being preserved after he died in 1955.
Yeah, that's always been a bit controversial, whether it was ethical or if it actually yielded any scientific insights.
So as we wrap up this deep dive into Einstein's life and work, based on this amazing biography, what are your biggest takeaways? What do you hope our listeners will remember?
For me, it's the sheer audacity of his thinking. He didn't just tweak existing ideas, he completely revolutionized our understanding of space, time, gravity, energy, and beyond the science, he was a deeply moral person who felt a responsibility to use his influence for good.
Couldn't have said it better myself. He truly went beyond physics and left his mark on science, culture, politics, everything. And it makes you wonder, especially thinking about how he struggled in that rigid school system early on, how can we change education to help cultivate more minds like his? That's something worth thinking about. Thanks for joining us for this deep dive.
Absolutely, it's been a pleasure.